Hey kiddos, we're going to jump right into our calculations that we've been working on with strong acids and strong bases. Now I'm going to merge all of this together at 27 and 28. We have a hydrobromic acid solution, so I'm going to go ahead and write my reaction down here. Gives me H plus, hydroic, remember came from ide, and bromide was the -1. If you can't get a reaction, if you don't remember the acid, do the best you can and continue to follow through on the mathematics, and you'll still get quite a bit of partial credit for that. So I have a pH equal to 3.2. Now this is going to be a backwards question. pH is going to give me my final H plus concentration, because you measure the pH after everything has happened. So my concentration of H plus is equal to 10 to the minus pH to the minus 3.2. And please double check my math here. It's always helpful. I should give away candy bars for people who find my little mistakes. I try to catch as many as I can, but it's going to happen. Okay, so that means that this number here is 6.31 times 10 to the minus 4th. Now remember, we started with 0 of each of these, and we end our acid with 0. So this must have been plus 1 over 1 times 6.31 times 10 to the minus 4th. So to go in this direction, we still just multiply by the mole ratio. So what that means is our original was 6.3 times 10 to the minus 4th. In other words, our concentration of H plus is equal to our concentration of HBr because it's a 1-to-1 mole ratio. If you state that, I will accept that as part of your work. I mean, that's about as simple as we can be with these types of reactions. Okay, I'm going to keep filling in the grids, but you can do them a little simpler. So we have nitric acid, HNO3, yields H plus NO3 minus. And at this time, it's simply asking me for my nitrate concentration. Well, since this is a 1-to-1 mole ratio, those will be equal to one another. So I'm going to use my pH to get my H plus, and then my H plus and my NO3 are equal to one another. So my H plus, I don't need to fill out the whole grid. It's not asking me really for any of the other components, so I'm not going to use it all. Use what's needed to get your mind moving. So my H plus is 10 to the minus 1.3, which is 5.01 times 10 to the minus 2 molar, which is also equal to my molarity of NO3 minus, because you've proven to me up here that you know that that's a 1-to-1 mole ratio. So that would be enough work for me. All right, the next one is barium hydroxide. It's a group 2 hydroxide. It's one of the few times we'll see a mole ratio that's not 1-to-1. All right, remember that's a 0, that's a 0, and that's a 0. Okay, now pH gets me to H plus, but H plus isn't showing up anywhere on this chart. So what we need to do is we need to go from pH to pOH. And then I can go to my OH minus concentration. And that is going to be my step into my problem solving grid. Okay, so if pH is 10.4, pOH is equal to 14 minus 10.4, and that is equal to 3.6. Therefore, my concentration of OH minus is equal to 10 to the minus 3.6. And that value goes in right here. It's 2.51 times 10 to the minus 4th. Okay? Now, you can use just simple dimensional analysis, or you can continue to fill in your grid. So this must have been, let me get a different color here, this must have been plus 2.51 times 10 to the minus 4th. Now, to get to my barium ion, I multiply by the mole ratio, 1 over 2. Remember, it's always where you're going to over where you're coming from, times 2.51 times 10 to the minus 4th. And so now this grid gives me my barium ion concentration, even if it doesn't ask. Okay, I'm showing you that the grid gives you a lot of good information. Now, this must have been minus, you multiply by the mole ratio, where you're going to over where you're coming from, 2.51 times 10 to the minus 4th. So that gives us our final answer up here of 1.26 times 10 to the minus 4th molar. Final answer. Assuming I did all my algebra right, okay? So we went from pH to POH, POH to OH, OH back to my barium hydroxide. So that was kind of my strategy there. So now we've got calcium hydroxide, 100% to calcium ion plus 2 hydroxides. Now this question asks a whole bunch of things. What's the calcium ion? That's that answer. What's the hydroxide? That's that answer. What's the pH? It's not really on this grid. But we are given H+. So we can calculate pH. H+ is 1.2 times 10 to the minus 12 molar. So if I take minus the log of that number, I get my pH equal to, I'm not going to rewrite that. That number goes in there. We've seen a lot of these. And so my pH is 11.92, which makes sense because we've got a base in the solution. Now, I want to get into my grid. So if I know my H+, 1.2 times 10 to the minus 12, times my OH minus, do you see how we're using those early formulas over and over again? And it's up to you to pick the right formula. Now, if you solve that for the OH minus, we get 8.33 times 10 to the minus 3 molar. Now to get my calcium ion, I just multiply by the mole ratio, 1/2 times 8.33 times 10 to the minus 3. And if you do that algebra, I got 4.17 times 10 to the minus 3 molar. So that was one of the answers it asked for. What's the calcium ion? Here's the second one. What's the hydroxide? And here's the third. What's the pH? Okay. Now, we're going to just push it a little bit further. This time, instead of giving us molarity, it gives us mass and volume. So we have to calculate our molarity of KOH. Now remember, molarity is moles per liter, or we can plug in for moles. Moles are mass over molar mass divided by liter of solution. I have 4.5 grams. If you calculate the molar mass of KOH, it's 56.11 grams per mole. Remember, you have to convert those milliliters to liters. So that's 0.500 liter. And I got 0.160 molar KOH. So that would go in here on my grid. none of that, none of that. Minus 0.160. Don't forget to multiply by your mole ratios, even if it's 1/1. I know it seems silly, but there are going to be times as we build on this knowledge where it's not 1/1, and you have to be prepared to do those. So now I know my OH concentration. So if I know my OH concentration, this is asking me what my pH is. And I noticed I got distracted and okay, sorry about that. I got distracted and I never finished this problem. So you can go from OH to POH and then to pH if you want, or that alternative route. Either way you go, you should get a pH equal to 13.20. Remember, pH is a unitless. It's one of the few numbers we'll see without units. All right, let's try one more. It's very tricky. This is as hard as they're going to get. So let's give this a shot. I have calcium hydroxide yields calcium ion plus 2 hydroxides. Now, the question is, what's the original molarity so that we can find the grams needed to make that molarity? So remember, molarity is mass over molar mass divided by liters. That's our ultimate goal. Is if I wanted to make this in the lab, if I needed a solution that was pH 10.2, how many grams of calcium hydroxide would I have to add? Very realistic example. So my first step is to go from pH to POH. So if my pH is 10.2, my POH is 3.8, because that sum has to equal 14. Okay. Now, if my POH is that, I take 10 to the minus 3.8, and I get 1.58 times 10 to the minus 4th molar. So now I'm going to go backwards. It doesn't ask me anything about the calcium ion, so I'm not going to worry about that so much. If I started at 0, that means the shift must have been plus this number. Now I want to get to my calcium hydroxide, and so I'm going to multiply by my mole ratio. 1 calcium hydroxide for every 2 moles of hydroxide. 1.58 times 10 to the minus 4th. So if I divide that out, I now have my molarity I was after. And I got 7.92 times 10 to the minus 5th molar. Now that's getting pretty tough. We've got a lot of partial credit laid out on the paper right now, but we're not quite where we need to be. So let me get myself a little bit more room here. I have to get to grams. So I'm going to take that 7.92 times 10 to the minus 5th mass over molar mass. My molar mass of calcium hydroxide, according to my little app on my iPhone, is this. I can't put milliliters. This is per liter, so it's 1.500 liters. And if I solve that, if I do my little rearranging in algebra, I got 8.81 times 10 to the minus 3 grams. And that, my kiddos, is my final answer for that. And I dare you, find my algebra, find my calculator slips. I'll give you a candy bar if you do. So until you do that, this is signing off.